Hello everyone, this is Kamis theory. So in this video, we're going to solve the lead code number 191, it's number of 1 bits. So basically they're given integer n and we have to find the number of set bits in the integer. Set bits means nothing but we already discussed about the set bit. It's nothing but it's a 1. Okay. So if the question is given as unset bit means it's a 0. Okay. So set bit means it's 1, nothing but it's a 1. Okay. So example, they are given an input 11 and the output is 3. How this output comes means in the input binary string there are 3 set bits. I already say set bit means 1. Okay. So in this example there are 3 set bits. So total of 3 set bits, therefore they return the output 1. Okay. So another example is 128. So in this example only 1 set bits are there. So we have to return that 1 set bits. So and also they are given another example 3. It's multiple numbers are there given. So we have to return how many set bits are there in the number. Okay. So yeah, totally there are 30 set bits are there. So that's why they return the 30 bits. I will explain how to execute this code. So before we dive into this example, we should know how to get the LSB of each number. Okay. So before I already said how to get this LSB by using the AND operator in the previous 2 to 3 videos. If you have time, just watch the video. I will explain clearly about how to get this value. Uh, no problem. I will tell this in this video. Okay. So I'm taking this example n is equal to 11 and okay. So this is the binary value of 11, nothing but 1011. Okay. So this is the binary value of 11. Okay. This is the binary value of 1. Okay. So I'm going to do this AND operation of n and 1. What will happen means it will return the LSB of the 11. Okay. LSB means nothing but it's a least significant bit. I mean, you can consider it as a fourth bit. Okay. So after that, we have to remove the LSB, right? So and we have to find this another consecutive number, right? So that's why we are doing this right shift operation. Right shift operation, what will happen means it remove the LSB bit and it add 0 to the MSB. Okay. So that's why 0, 1, 0 came here. Okay. So this 1011 is transferred to 0100 by using the right shift operator. Okay. So again we are doing the AND operation with this output. I mean this right shifted n. Okay. This is nothing but it's a n. Okay. So, and I already say AND operation will return the LSB bit. So here the LSB is still a 1, it will return the again 1. Okay. After that we are going to do the right shift, then we are doing the AND operation with 1. Finally, it return the 0. Okay. What will here? Why 0 is occurs means the LSB bit of n is 0. Okay. So this is the right shift of n. Okay. Before this value is get from by right shift by 1. So I will tell you how to right shift the one. Okay. So then the output is what it returns. I mean, then we are doing the right shift operation by 1. So the output is 1. Then again we are doing the AND operations. It returns the LSB bit of n. So this LSB is stored in the p variable, and finally it returns the. I mean, it goes to the right shift by 1. So again the condition is fails, the loop will terminate. Okay, I will write the code. If, after that I explain, you will clearly understand about how it works. Okay. So first of all, I just initialize. Okay, I mean I will do the while loop operation. Okay, while n greater than 0. So then I take one variable. For example, it's p. I do the AND operation with n and 1. Again, if p equal to 1 means I just increment another variable. I will declare this in this part. Okay. Okay. I declare int c is equal to 0 and I increment c plus plus when the p equal to 1. P is nothing but it's an AND operation of n and 1. Okay. So then, okay. in this code, we'll execute AND operation and we'll find whether the LSB is 1 and we will increment its value. Okay. So this is the working of this code. Okay. Right. Sure. Okay. Yeah. So after the completing this, after we checking the LSB bit, we have to right shift, right? So how we right shift means n greater than equal to 1. This is the right shift operator. Double greater than is represented as a right shift, and I right shift by 1. Okay, it's equal to n equal to n right shift of 1. This is the expandable format. Okay, yeah. Hmm. I think this code will just set. Okay, it's int, so that's why just return C. Okay. So we have to count the number of words. Okay. I just that's why I'm using C operator. I mean that's why I'm using C variable to count that number of ones in that entire binary numbers. Okay. So I just run this code. Yeah, it's working. Okay. Let's submit this code. Preparing a mental. Okay, fine. Okay. I will explain. Okay. So here I'm initializing int C is equal to 0. C is nothing but I'm using this variable to find the number of ones in the entire binary numbers. Okay. So I'm checking while n greater than equal to 0, then I'm using p variable to find the AND operation of n and 1. Okay. So why I'm using this n and 1 means it returns the LSB bit of the n. Okay. So after finding the LSB bit, I'm checking that whether the LSB is 1 or not. Okay. If the condition is satisfied means we have to increment the C. Okay. It's not, but why I'm incrementing C means it returns the number of ones in the entire binary numbers. Okay, so after completing this, we have to right shift the n value. Then only we have to move the upcoming variables, consequent variables. Okay, that's consequent bits. Okay, sorry, variable. Okay, here the example n is equal to 11 is 1011 and I'm doing the AND operation. This is AND operation. Don't confuse. This is AND operation. Okay, n and 1 it returns the 1 when 1 this 1 is nothing but it's the LSB bit of n. Okay, so this 1 is stored in the p and I'm right shifting this n to n. So what will happen means the LSB bit will be removed, another 0 will added to the MSB. So here the 0 is added at the MSB and the LSB is removed. This one is moved one step forward because I'm right shift by 1. Okay, if I'm right shift by 2 means this one also removed, another 0 is added at the MSB. Okay, this is how right shift operation work. So consequently I'm checking all the bits in the n and finally uh, the entire n will become 0. So the entire n becomes 0 and while loop it checks n greater than or equal to 0. The condition fails, the loop will be terminated. So and finally the entire output is returned. Okay, this is how this code works. So this is called Hamming weight. Okay, how many set bits are there in the code? Okay. So I think this video is very useful to understand about the set bits and operation and right shift. So yeah, uh, I will explain the another type of code. I mean, I will explain the another bit based problems in upcoming videos. So thanks for watching this video.